Welcome to another tutorial about Longhorn Physics. In this problem we were going to figure out how much work is done on an object being pushed across the floor. So first thing we need to do is we need to go over the units, the equation, and make sure we fully understand all these things before we even attempt to solve the problem. Our equation for work is just force times distance, but here's where we need to make sure we understand the concept. The force and the direction of the force must be uh, parallel or in the same direction. So for example, this guy applies a force to move the box this way, then the direction the box moves must be in the same um, direction, or he actually is not doing any work in the physics sense. So in this case, he will be. Now let's say you take a waiter and he's carrying a tray of glasses. How much work is he actually doing? Well, the answer is none. And he might be sweating, he might be wishing he had another job, but he's applying the force this way, and the tray is moving this way. So they are not in the same direction or parallel to each other. So in the physics sense, no work is being done by the waiter, even though he feels like he's doing a lot of work. So in all the tutorials, I'd like to always go over the definitions and make sure you understand the units, the way they match up with the various symbols. If not, there's no way you're going to be able to solve a lot of the more difficult problems. So let's go back to the concept of work again, and the equation is force times distance. What you need to know is each variable, or we also call them symbols, and their matching unit. Why do you need to know this? So that you can solve the problem, because you're going to have to match the units with the symbols of the equation. So for work, uh, work and joules go together, as you see right here. And force in physics is always newtons, and then distance is the letter D for the symbol, and the units are in meters. So here's also the definitions for work, force, and distance here. Alright, so now that we know the units and the symbols for the equation, we kind of play Sesame Street and match them up. I like to use a method called the circle label method to organize the data, which will help you solve the problem. So first thing we do is we scan the problem. An object is pushed across the floor for a distance of 3 meters with a force of 500 newtons. How much work is done? So if we know that the force and the direction of the force are in the same direction, then we're going to have to calculate. Too bad the answer is not 0 in this case. Uh, so we look for meters, and we know that matches with the symbol D in the equation. Then we scan the problem here, and we see newtons, so we know that goes with force. And then work is what we're actually looking for. Alright, so now that we've circled and labeled, uh, there are certain equations in physics that are what I like to use to solve them is called a math triangle. A math triangle is very simple. It's basically anything that fits the form A equals B times C. And it makes it so much easier to see the algebra. We know the language of mathematics, or for physics, is mathematics. So, for example here, the equation W equals F times D fits perfectly in the form A equals B times C. So the A, B, C. So A always goes on the top, and then the two letters on the right side of the equal sign, or on the left side, the two that are by themselves, go on the bottom parts of this, what we call a math triangle. And then it's very easy to see the algebra. You're either going to multiply or divide. So in this case, we plug in our 500 for force right here, and then for distance, we plug in 3 meters. And the way you do the arithmetic for the math triangle is you simply, if you're looking for the top symbol, you just multiply the two bottom boxes. If we were looking for D, we'd multiply, or we'd divide W by F. And if we were looking for force, we'd take the work and divide it by the distance. So it should be real easy to see the arithmetic here. So work in this case is just 500 times 3. So 500 newtons times 3 meters gives us 1500 joules. A joule is also a newton meter. So again, we're always hoping to find equations that fit the form A equals B times C. If we know the units and we know the symbols and how they match, and we're able to plug them into a math triangle, it surely makes the problem a lot easier.